students. Today is going to be your last part for the arithmetic progression. We are doing some very important questions from your exercise 6.2. After question number 12, I'm picking up some questions that are algebraic types, proving types, actually, proving types, showing types. And I will also take up a question from your solve example, one of the very important ones. Okay, so let's see. Let's start with question number 12. It's saying find the sum of the first 50 terms of an AP whose nth term is given as 3 minus 2n. Okay, look. We have to find the sum of the first 50 terms. The number of terms that you are supposed to obtain the sum of is given as 50. But here, instead of giving you the arithmetic progression, you are given the nth term. Okay, from this nth term, I believe you can find out the first term, second term, third term, and so on. Very easy. And you have to find out the sum of the first 50 terms. So S50, this will look like n by 2, 2a plus n minus 1d. Unless you don't have the arithmetic progression, we cannot have the value of a and d, right? N is already given. Okay, let's see. Very simple. Here, let's start the solution. What is the nth term? Nth term is 3 minus twice n. If I wish to find out the first term, that means here this n will be replaced with 1 because the n was replaced with 1, right? In the left-hand side. So right-hand side do the same thing. We will replace the n with 1. So we get 3 minus 2, which is equal to 1. You can obtain a second term also. 3 minus 2 into 2. The n here is replaced with 2. If you want to obtain the third term, you can again do the same thing. You just replace the n with 3. So this one, how much do we obtain? We obtain 3 minus 4, which is minus 1. Let's find out of the third term. Okay, third term is 3 minus 2 into 3. This will be 3 minus 6. This is minus 3. Okay, now we can write out the sequence of the numbers that we are obtaining. Here is 1, next is minus 1, next is minus 3. So the sequence is what? The sequence is, we can write it as 1, minus 1, next is minus 3. Look, there is a common difference of how much? Minus 2, minus 2. Next will be minus 2 also, the common difference. Minus 3, minus 2, next will be minus 5. You can do the finding out part by just putting the fourth term by putting n as 4 here. You will obtain the value as how much? The next value will be minus 5. You do the same here. You just put the value of n as 4 to 4 is 8, 3 minus 8. You will obtain minus 5. We can continue further also minus 7 and then so on. Look, there is a difference of minus 2 between its consecutive term. That means there is a common difference. If there is a common difference, then the sequence is an AP, right? So you can replace the word here. You can replace the word sequence as the arithmetic progression. Okay, better to replace it. I can replace the word sequence as the APs. Okay, now time to find out the first term and common difference because the number of term is already given as 50 term in order to obtain the sum. So here, here A is how much? 1. D is subtract any two consecutive term, subtract 1 from minus 1. So minus 1, minus 1. So we get how much? Minus 2. Now we have to obtain the sum of 50 terms, right? The first 50 terms of the arithmetic progression. So we will write S50 is equal to n by 2, 2a plus n minus 1d. We have to put the value of n as 50, a as 1, d as minus 2. Okay, let's put it, let's do this part on the right hand side. Now sum of the 50 terms, how much is it? N is 50 by 2. 2 into a is 1 plus n minus 1, how much will it be? It will be 50 minus 1. And d is minus 2 since the value of d is a negative number. Don't forget the minus sign here. And you have to enclose the negative value inside brackets. Okay, so let's continue further. Solving this part is easy, right? You just have to do multiplication, division, addition, that sort of thing. Okay, 50 by 2, 2 into 1 is 2, plus minus is minus. 50 minus 1 is 49 into 2. Look what I have done. I have just multiplied minus and plus sign here. So plus minus is minus. So I have put the plus as minus sign. Continue. 50 by 2, 2 minus 49 into 2 is 98. So we get 50 by 2 is equal into minus 96. This will be minus 48. Multiply it, we are going to get uh, 5 by 40, 5 4 are 20. So we will get 2400. We're getting the sum as negative value, right? Because most of the arithmetic progression is a negative number except for the first one. So here, the trick is nth term is given. You just obtain first term, second term, third term, fourth term, fifth term. You can continue whatever the term that you want to find out. It's okay once the nth term is given here. If nth term is given, first term, second term, third term, we found them out. We just find out the value of a and d from them by writing the sequence like this. And then we find out the sum of the 50 term. Easy stuff. Okay, question number 13 is slightly similar, but question number 13, what is given there is the sum of n terms. Okay, slightly different. You try it out. If you don't know, you may forward the question to me. I will solve it for you. But for now, I will leave it as a practice question. Okay, coming to the next question. Next question is very important. This question can be given a 5 mark or a 4 mark. Okay, it has already been asked several times in the board examination in the past. So what the question is saying is, in an AP, we have an arithmetic progression. So we have first term common difference. If the sum of the first m terms is how much? Is equal to n. Okay. And what else is given? That of the first n terms is m. One more. Question wants what? Prove that. Question wants us to prove the sum of the first m plus n terms is minus m plus n. When you have a question such as prove that, so that you just have to put what is given first. What is the hint given first? What we need to prove or we need to show. You need to have that clarity in your mind. And then you just plan the strategy in order to arrive at how to prove and how to solve. So for this one, what is given is sum of the first m terms. Sum of the first m terms, I'm denoting it as Sm. Sum of the first m terms is how much? It's equal to n. Sum of the first m terms is equal to n. What more? That of the first n term. That means the question is still saying sum, okay? Sum of the first n terms. Now it used to be m terms. Now it comes into n terms is how much? M. So sum of the n terms is how much? It's m. Okay, what is the meaning of sum of m terms, sum of n terms? You know, when we learned the formula for sum of n terms, we had the formula like this. This is a general formula, right? Yeah, what did the n represent? N represent the number of terms. Can be any value. If the number of terms is given as 50, you have to replace the value of n as 50. This represent the sum of n terms. If I ask you to find the sum of m terms, m is just a different number other than n, okay? Just a change of variable, could be the same number also. M is just a different variable, different value than n. So if I want to write Sm, I have to replace the n here with what? M. How will the formula change then? It will change like this. M by 2, 2a plus, the n here will also be replaced by m. Look, this n is replaced by m, this n is also replaced by m. That's it, that's the simple sense, nothing else. So according to the question, sum of the m term is given as n, sum of the n terms is given as m. What do we need? We need to prove that the sum of the first m plus n term is how much? Minus m plus n. Sum of the first m plus n terms. Next comes sum of m plus n terms is equal to how much? Minus sum of m plus n terms. Only this n and m, it is being replaced with what? M plus n. How will I write this part? Sum of m plus n in terms of formula. We will have, when we had the sum of n terms, there was n number of terms. That's why there is n here, n here. For m number of terms, we have m here, m here. Now we have m plus n number of terms. That means this n or this m, they will be replaced with what now? M plus n. Okay, the formula will look like this now. We will have m plus n in place of n, 2a plus. This n or m, it will be replaced with m plus n. So we are going to have m plus n minus 1. D. Okay, now keep these three formulas in mind. If I want sum of n terms, this is the formula. If I want sum of m terms, this is the formula. And if I want the sum of m plus n term, this is the formula. Question wants us to prove that sum of m plus n is minus close bracket m plus n. This is what we have to prove. This is our goal. Sum of m plus n, we have to obtain it as minus m plus n. This is the given. Okay, I believe everything is clear, right? What is given, what is to prove. So since the a and d is there when we form the equation, we will first have to define what a and d are. Okay, let's start a proper solution. Solution by equation. You have to start with let a and d be the first term and common difference of the AP. What do we have now? According to the first part, sum of m terms is given as n. Now let us replace the Sm with its respective formula. We will have m by n, sorry, m by 2, 2a plus m minus 1d. Let's enclose them in third brackets, more easier to write, is equal to n. And what else is given? Sn is equal to m. So we will write n by 2, 2a plus n minus 1d is equal to. This is the first one given. This is the second one given. We want to obtain what? We want to obtain sum of m plus n terms as what? Minus m plus n. Since you already know the formula for this three, I'm rubbing this over. Okay, it's not necessary here anymore. Okay, let me change this equation, this part a little bit. Let's take the 2 to the other side. So it will become 2n, right? And multiply m inside. So m and twice a, we will have twice am plus m and this whole thing. We will put m in the front, m whole bracket m minus 1d. Look, m is multiplied with this and this. 2 is gone to the other side. The 2 is the denominator, so on the other side it will definitely become a multiplication. So we will have twice m. This is first equation. And then also, okay, do the same thing on the second one. We will take 2 to the other side, multiply n with this and this. So we are obtaining twice an and n minus 1d is equal to twice n. This is equation number. Okay, now let's subtract equation 1 and 2. Let's subtract equation 1 and 2. You can subtract 2 from 1 or 1 from 2, whatever your choice is. So I'm subtracting equation 1 and 2, 2 from equation 1 actually. So let me write subtracting equation 1 from equation 2. What's the value now? You subtract equation 1 from equation 2. Oh, I'm sorry. I'm writing this in the reverse order. Equation 2 from 1. Okay. So what's the value that we are obtaining now? Left hand side twice am plus m minus 1 d. Let's enclose them inside third bracket minus twice an plus n minus 1 d. And on the right hand side we are going to have twice n minus twice n. Okay, everything good? Left hand side, this part is here, this part is here. The subtraction of the left hand side. And for the right hand side, this part is here, this part is here. Easy. Okay, let's keep the last line and let me remove everything else. Okay. So what next? Let's open the third bracket. Place them twice am plus m minus 1d minus twice an. Let's multiply the two signs, minus n plus. We obtain minus here. Okay, look at these two. I can take out the 2 as common factor. Okay, let's combine the like terms. This one and this one are the like because they have 2 and both of them. These two are like term because they have d on both of them. So between these two, I can take out 2a as common factor, right? 2a here, 2a here. So if I take out the 2a as common factor, m is remaining in the first one, and from the second, I'm in these two. Okay. What about these two? D is common here in both of them. So I have m minus 1 remaining from the first one and n minus 1 remaining from the second. And we will have d behind. D is taken as common factor. Okay, right hand side, there is no change. Twice a, m minus n. We are trying to take out m minus n as common factor from all the terms. Okay, so let's open this bracket. We will have m square minus m minus n square plus 1, sorry, n square plus n d. We're just opening the first bracket by multiplication, multiply this and this, this and this. So we just have a sign multiplication here, minus and minus. That's why there is a plus sign here also. Is equal to twice n minus m. Okay, no need for the last line. So don't change the first term. M square and n square can be taken as common factor. No, we are putting them together. The terms with the square, we are putting them together first. And the minus m here, and plus n. Let's just enclose this with third bracket and no change on the other. Okay, we can express this, right? A square minus b square form, we will have a plus b and a minus b, right? But instead of a and b, we have m and n. And the remaining, look, no change here, first term. The first two term, I can write it as m plus n, m minus n. The remaining two, we can take out minus 1 as common factor, so that we will obtain minus m minus n. So we will have minus 1 here, m minus n. There is d here. And then in order to obtain m minus n, I can reverse this. N minus m, it can be written as minus m plus n. Look, the n has positive sign, m has negative sign. And take the minus as common factor, we will have minus m minus n. So this n minus m, change it like this, minus 2 m minus n. Because we obtain a minus sign in the front, the whole thing is exchanged here. It turns into m minus n. So here is an m minus n, here is an m minus n. This term is together, so we can take out the m minus n common factor between these two terms. So twice a m minus n plus, take out the m minus n as common factor, m minus n is there. What is remaining? If I take out these two, there is an m plus n here, and there is a minus 1. So put the remaining stuff, m plus n minus 1, and there is a d outside is equal to, look, m minus n, m minus n, m minus n. The m minus n is in all the three terms on both sides. So you can just cancel them out. How are we canceling them out? Because if I take m minus n from here as common factor, then 2a will be remaining, m plus n minus 1d will be remaining. And we can take the m minus n to the other side so that the m minus n's are cancelled. Okay. If everything is in all the terms on both sides of the equation, then we can cancel it out. Cancel this out, cancel this out, cancel this out. What is remaining? Let me rub the above steps. So what we are going to have is, we have twice a remaining, m plus n minus 1d remaining is equal to minus 2. Okay, fine. We will put this as equation number. I think we have equation 1 and 2 already, right? So we will have this as equation number 3. Okay, why we are obtaining this is because we wanted to obtain the sum of the first m plus n terms. Sum of the first m plus n terms. What did we have? S m plus n. What was the formula? M plus n by 2 twice a plus m plus n minus 1d. You remember this, right? From the three formulas that we have wrote in the beginning. Okay, the thing is, why we went to all the trouble in taking out m minus n common factor and then canceling it out in the previous 6-7 step is because we want to obtain the value of this. Because this value is here, look, exactly the same, right? So we can replace the value of this as minus 2. Okay, now we will say here, putting the value from equation number 3, we are going to have s m plus n is equal to m plus n divided by 2. And instead of this portion from equation number 3, we are going to put this value right here. So we will have minus 2. 2 and 2 got cancelled. We have 1 here. Denominator 1, no need to take it, right? So what we are left with is, there is a minus 1 remaining. Don't forget the minus sign. And since this is a binomial, there are two of them, you have to enclose the m plus n in brackets. So we will have minus m plus n. What's the value of sum of m plus n now? It's minus m plus n. Okay, that's exactly what the question wants us to prove, correct? So it's easy. What you have to do is, in the sum for m plus n terms, we have this term. This term, you have to find it out by using the above steps. You subtract the equation 1 and 2, right? and you take out the common factors, cancel it out in from both sides, and then you obtain the value of this as we have got in equation 3. V1 minus 2. That's how you obtain this value right here. Okay, this is a little long, but practice it at least 2 or 3 times. Okay. Now let's look at the next question. Next question is, it has been asked too many times. Okay, so better learn to do this. Let's see the question. The sum of the first n, twice n, thrice n terms of an AP are S1, S2, S3 respectively. So we have to show S3 is equal to 3 whole bracket S2 minus S1. So S1, S2, and S3, what does these three terms represent? S1 is what? S1 is, this is the sum of n terms according to the question. What about S2? S2 is equal to sum of, this n is changed into what now? Twice n. Sum of twice n terms. And what about S3? This will be sum of thrice n terms. So, we can write the expression for S1, S2, S3 separately just by using n by 2, 2a plus n minus 1d. Since these three sums represent a sum for the same arithmetic progression, the only difference is that the number of terms in these three are different, right? So how can we write the expression of S1, S2, and S3? Look, S1, I can write it as n by 2, 2a plus n minus 1d. This is the same formula as we have already learned. What about S2? S2 is, you just have to change the n here with twice n. This is the same arithmetic progression, so no need to change the first term and the common difference. So the expression for S2 will look like what? Twice n by 2, twice a plus, twice n minus 1d. What about S3? Same thing except for you have to change the twice n with thrice n. S1 we have n number of terms. S2 we have twice n number of terms. S3 we are going to have thrice n number of terms. Okay, thrice n divided by 2, 2a plus thrice n minus 1d. So the thing is, we have to prove this equation right here. You can start from the left hand side or right hand side, whatever your choice is. This is just an algebraic calculation. Okay, better to start from the right hand side. You know the value for S2, know the value for S1, the expressions I mean, and you subtract S2 minus S1, multiply it by the 3 in the front, and see if we obtain S3. Okay, let's do the proper solution right here. So we are going to have the solution is, first of all, you have to take what a and d are. Let a is equal to first term of the arithmetic progression, and you know d is the common difference of the arithmetic progression. As given by the question, you can write the expression for S1. So this is, it looks like this. Make it equation 1. What about S2? We get twice n by 2, twice a plus, twice n minus 1d. This is equation number 2. Write the formula for S3 also. Thrice n by 2, 2a plus, thrice n minus 1d. Make it equation 3. Okay, our goal is to prove this. So let's start from the right hand side. Okay, right hand side is 3 whole bracket S2 minus S1. In this right hand side, we will just put in the value for S2 and S1. That's it. You do some algebraic calculation, and so let's see if we will be able to obtain S3 or not. Okay, so right hand side, we have 3 S2 minus S1. Let's put in the value from equation 1 and 2. 3, keep it. I'm putting a first bracket in the front. S2 is, it's twice n divided by 2. Third bracket, 2a plus 2n minus 1d. Minus, what about S1? We have n by 2, 2a plus n minus 1d. What can be taken out as common factor? Look, I mean between these two terms. Okay, what can be taken out as common factor? The inside is not similar. There is twice a, d, but here is twice n minus 1 and n minus 1. Don't make the mistake of taking this whole term as common factor. That will be a wrong calculation, right? What we can take out as common factor is this part. This n right here, it can be taken out as common factor. So let us take the n out. Also, the 2 here, it's common factor. That means we can take out the whole n by 2 as common factor from these two terms. Take it out now. We are going to have thrice n by 2 is taken out as common factor. What is remaining? Let's enclose by third bracket, okay? Since n by 2 is taken, the 2 here will be remaining, including this portion right here. So 2 second bracket twice a plus twice n minus 1d bracket close. Minus what about here? This n by 2 part is taken away as common factor. That means this part will be remaining. So we will have twice a plus n minus 1d. Okay, we have already used s1 and s2 here, but we haven't used the s3 yet. So let's just take it away. Let's put it on the side. Let's put it on the side and then erase the above steps. Okay, now let's continue this part here. I'm rubbing this up also. Okay, look, let's continue this part here. Implies that we are calculating 3s2 minus s1. So what we have got on the right hand side is we have got thrice n divided by 2. And let's open this bracket. Okay, let's open this bracket and this bracket. This can be opened just by multiplying the sign. Just multiply minus and plus, we get minus. But for this part, you have to multiply 2 and this part and 2 and this part. So what we are going to have is we are going to have, if you multiply 2 and 2a, it's 4a, right? Continue, multiply 2 and the next part twice n minus 1 d minus, if I open this bracket, so we will have twice a and n minus 1 d, twice a minus n minus 1 d. We're just opening the second bracket, okay? Okay, and then this part is for reference. I'm circling this. Okay, now let's combine the like terms 4a and the twice a. We can subtract them. 4a minus twice a, we have got twice a now. So what we are left with is we have got thrice n by 2, no change in the front part. We have got 4a minus twice a. Okay, let it be. What about these two parts? D can be taken out as common factor, right? But first, let's keep it 2 whole twice n minus 1d minus n minus 1d. You can take out common factor d from these two, right? From these two terms. So thrice n by 2. 4a minus 2a is twice a. Plus, if I take out d as common factor, this whole portion is remain. 2 whole bracket twice n minus 1. But you can multiply this. 2 2s are 4 and 2 1s are 2. So instead of keeping 2 whole bracket twice n minus 1, you can multiply 4n. You can put it as 4n minus 2. So we have got 4n minus 2 minus d are taken out. So n minus 1 will be remaining here. But since minus multiplies it, this minus sign will turn into plus sign. So we have got n plus 1. Whole bracket. D is taken as common factor. Okay, don't get confused with the changes that I have made here. It's very simple. Look, we have to put this part here, but I don't want to lose one more step. So the easiest way to shorten it is you just multiply 2 and twice n. We have got 4 n here. 2 and 1, we have got 2 here. What about this part? This part, there is a minus sign. Minus n will be here. Okay, there it is. Minus is plus, so there is plus sign. So finally, what we are able to obtain is thrice n divided by 2, twice a plus. So 4n and n, we have to subtract them because one is positive, one is negative. 4n minus n is 3n, right? So 3n. What about minus 2 plus 1? Minus 2 plus 1 is minus 1. Minus 1 whole bracket d. Okay, what we are doing here is we calculate the right hand side. Right hand side is 3 whole bracket s2 minus s1. You just put the value of s2 minus s1 based on its number of terms. So now let's look at this portion. This portion we have obtained it by calculating this part right here, 3s2 minus s1. So if you look here, the original expression for s3 that we put in equation number 3 was thrice n by 2, twice a plus, thrice n minus 1. We are obtaining the exact same thing, right? So you can just write is equal to s3. S3 is in the left hand side, right? We calculated the right hand side and we are able to obtain the left hand side. That means left hand side is equal to right hand side. So we will say hence proof. The only thing that you need to do here is you just need to know what will be the expression for S1, S2, and S3. You know the formula for sum of n terms, right? N by 2 twice a plus n minus 1d. In S1, you put the n in the formula as n. In S2, you put the n as what? Twice n. In S3, you put the n as what? Twice n. That's the only difference. Then you just have to calculate the right hand side. You can start from the left hand side also. Left hand side is okay. You can start, but you have to be a little bit constructive in there. So better not to do from the left hand side. Better start from the right hand side. You have to just subtract S2 and S1, multiply it by 3. That's easier that. Okay, now let's see the next question. 15 is easier. This question, I am taking it up from solve example question number 17 from your arithmetic progression chapter. This is a solve example. This is not from the exercise 6.2. Okay, let's see what the question is saying. Sum of the first P, Q, R terms of an AP are A, B, C respectively. Okay, let's just understand this part first. What is this part saying first? Sum of first, when I say Sn, Sn is what? Sum of n terms. Sum of n terms. Okay, look, if I write 2, 3, 4, 5, 6, how many number of terms are there? There are 5 of them. If I obtain S5, that is the sum of the 5 terms, we will have n by 2 twice a plus n minus 1 t. If I add more terms, 7, 8, 9. S5 means we are adding 5 terms. Which 5 terms? This, and this. The first 5, okay. We are not taking randomly like this. There are 5 of them, right? 2, 3, 6, 8, 9. But they are not the first 5 terms. The first 5 terms are 2, 3, 4, 5, and 6. So when you calculate the formula for, when you calculate the sum using the formula for Sn, what you are calculating is you are actually calculating the sum of first n terms. You know the meaning of first n terms, right? I just explained. Okay, now the question is saying the sum of the first p term. We know the formula for n term. Sum of the first p term, Sp. Let's represent it by Sp, sum of the first p term. So, and sum of the first q term and sum of the first r term. These are given as what now? A, B, and C. Sum of the first p term is equal to A. Sum of the first q term is equal to B. Sum of the first r term is equal to C. This is given. We're given an arithmetic progression, same arithmetic progression, but we take different number of terms in the arithmetic progression. And we are given the sums also as A, B, and C. Question 1 is to show what? Show that this thing, A by P whole bracket Q minus R, B by Q whole bracket R minus P, C by R P minus Q is equal to 0. Okay, so A by P, B by Q, C by R, you can obtain from these 3 equations. All right. After that, multiply each term by Q minus R minus P, P minus Q, and then add them. Simple as that. So what is given here? These 3 is given. Okay. You have to make it as an equation. So let's start a proper solution. You have to start with let A and D be the first term and common difference of the AP respective. One problem here. Sum of the first P term is also equal to A, right? So there is a conflict on writing A as the first term. So better we write it as A1. Okay. So we have A1 as the first term and D as the common difference of the particular AP we are dealing. What are given here by question? Sum of the first P term is equal to A. How are we going to write the sum of the first P term? Let's write on the right part. Sum of the first P term, we are going to write it as P by 2, 2A plus P minus 1. This is equal to A. Okay, one more thing. Look, we wanted A by P. We have to calculate this part. In order to calculate this part, we have to obtain A by P, B by Q, C by R. So how do we obtain A by P? We have to take the P to the other side. So what we are left with is we have got half left, twice A plus P minus 1D is still there. Take P to the other side, it will become A by P. Let's make it as equation number. Wait, one more thing. Is A by P enough? No. we have to multiply with q minus r also. A by b we have obtained by ourselves this part. So what about the missing part, q minus r? Multiply it on both sides. Okay. So we will say here multiply q minus r on both sides. So we have got here half second bracket twice a plus b minus 1d. We are multiplying this with q minus r is equal to a by b q minus r. Okay, look what we have done here. The sum of the first p term is given like this. We expand the sum of first p term as this formula. You already know this formula, right? And since we have to obtain this part, well, first of all, we obtain a by b. Yeah, we take the p to the other side. We obtain a by b first. What else is missing in this term? Q minus r is missing. So you multiply q minus r on both sides. So a by b whole bracket q minus r half 2a plus b minus 1d whole bracket q minus r. What this term? Okay, now this whole term is obtained. Sum of the first q term is how much? It's b. So from that, I think I can obtain this term also. So let's make it as equation number 1. Make it as equation number 1. So next, sum of the first q terms, sq 2a plus q minus 1d is equal to b. We wanted this part, remember, b by q whole bracket r minus b. But take this to the other side, implies that half twice a plus q minus 1d is equal to b by q. This is not enough. You have to multiply r minus q on both sides like we have done in the equation number 1. So you say here multiplying both sides by r minus b. What do we obtain now? We obtain half twice a plus q minus 1d whole bracket r minus b is equal to b by q r minus b. We have obtained this part here. Now from the formula for sum of q terms, we have obtained this part right here. This part is missing, right? So we will be able to obtain this from sum of the first q term. So let's make it this as equation number 2. So let me erase everything else. The part that we are going to need is this part and this part. Okay. So let's put this part separately. Okay, what about the last one? The sum of the first r term is equal to what? C. So we will write SR is equal to C. SR, we are going to write it as r by 2 twice a plus r minus 1 whole bracket d is equal to C. You repeat the same process as we have done in the earlier two equations. We have got half twice a plus r minus 1d C by r. Then we will multiply both sides by what? P minus q. Okay, so in this step we have multiplying both sides by equation by p minus q. Okay, so let me put this as equation number 3. Okay, look, we have obtained this part here, right here, this part here, right here. What about this part? We have obtained it right here. What we have to do is we have to add all the 3. Okay, let's add equation 1, 2, and 3 in order to obtain the left hand side on this part. So I'm rubbing this off, except the equation number 3, I'm keeping it. Okay, you cannot skip one single step when you calculate it in the examination. Okay, why I'm rubbing off is because of the space issue, lack of space. So let's add equation 1, 2, and 3. Adding equation 1 and 2 and 3. Add them at the left hand sides. Left hand sides, half, half, half is on all of them, all the 3. Take it out as common factor. What are remaining? This part, and this part, you have to add them. So just keep it there. Twice a plus p minus 1d q minus r plus next one twice a plus q minus 1d r minus p plus the last one. For this one we have written it here. Remember, half is taken out as common factor. This one we have taken it here, and this one you have to put it here somewhere. So we will have twice a plus r minus 1 d whole bracket p minus q. So that is the left hand side. We have added the left hand side, so no need for the left hand side anymore. Get the right hand sides now. Right hand side, we are going to obtain this, which is this part right here. So we will put is equal to a by p q minus r plus p by q r minus p plus c by r p minus q. Okay, so when we added the two equations, equation 1, 2, and 3, left hand side we have obtained this, right hand side we have obtained this. Okay, you can reverse the sides. Okay, you can reverse the sides and then put it where it is. Right now we have to solve this part, the left hand side. This is this part. What about the other side? Other side is 0. So when you solve this portion here, you have to obtain 0. Okay, so there are lots of terms to multiply. So let me rewrite the equation. I'm going to exchange the side, left hand side, the right hand side. Let's put it on this side here. A by p q minus r plus b by q r minus p plus c by r p minus q. What about the right hand side? Right hand side, half is taken as common factor. I'm just rewriting it. Okay, no change there. Plus last one. Okay, so I'm rubbing this part. Okay, since we have just rewritten this. Okay, now let's continue this part here. No need to change the left hand side. What we have to calculate is this right hand side part. Okay, right hand side part. So let me start with is equal to the left hand side. Let it be. We are not going to change this because it's this part. So right hand side, let's just calculate it. Keep the half there. Half is okay. And let's start multiplying twice a and this, twice a and this. So we are going to get twice a q minus twice a r. What about these two? P minus 1d and q, p minus 1d and r. So I'm writing like this. Let's just multiply them. Okay, pq pr here, pq minus pr, minus 1 and q is minus q, minus 1 and a minus r is plus r. So we have got pq minus pr minus q plus r, and remember there is a d outside. So we have expanded this part. Come to the next part. Okay, come to this part. So twice a and r is multiplied, twice a and p is multiplied. So we are going to obtain, there is a plus sign. Okay, twice ar minus twice ap plus, look, multiply q minus 1 and r minus p, put the d outside. Q and r is qr, q and p is qp. So I can write it as pq, right? Qp is pq. Minus 1 and r is minus r. Minus and minus is plus, so we will have plus p. There is a d outside. Do the same thing here. Twice a and p, twice a and q, twice ap minus twice aq. Multiply this and this. R and p is rp, so I can just write pr, right? So plus pr. R and q is qr minus qr minus 1 and p is p, minus minus is plus, minus 1 and q is plus q. Close the third bracket. Okay. Remember that we are not doing anything for the left hand side. Okay, left hand side we have to keep it as it is because we are calculating this part. So look at this 6, 2aq minus 2ar, 2ar minus twice ap, 2ap minus twice aq. So I can cancel them. Look, twice ar can be cancelled with twice ar because 1 is minus, 1 is plus. Twice aq and twice aq can be cancelled. Twice ap and twice ap, they can be cancelled again. What are remaining? Okay, so left hand side I'm writing up here. Let's rough this up. Okay, what are remaining now is equal to, this part is remaining, this part is remaining, this part is remaining. In all of them, d is common factor. So if I take half d as common factor outside, put the remaining stuff, pq minus pr minus q plus r. There is a plus sign in between, in front of the bracket. So when you open the brackets, it's going to be the same. The signs are going to be the same. So just open as it is. No need to multiply sign. Look, pq, pq, cancel out, right? PQ and PQ can be cancelled out. PR and PR can be cancelled out. QR and QR can be cancelled out. Minus Q can be cancelled out with plus Q. R can be cancelled out with R. P can be cancelled out with P. No term is left. So this means we are going to have half, and we use green. We have got half D into 0. So we have got how much? 0. Look, when you calculate this, we want to obtain 0. We have calculated it, we obtain 0. Keep in mind how we obtain this. Okay, this is a slightly long question compared to the questions that we have solved earlier. So keep in mind how we obtain A by P, how we obtain A by P whole Q minus R. So once we know how we obtain the first term, you know the process, you repeat it for the next two, right? And then you add them, you make them as equation 1, 2, and 3, and then you add them. Addition is a very long process unless you are very good with factorization, unless you don't practice a lot, there is a high chance that you will not be able to obtain 0 as the last value. Okay, the multiplication, it's not tough, it's easy, but slight mix up of sign, a small mistake of a lack of multiplication that will just cost you the whole thing. Okay, so better prepare it by doing this at least 2 or 3 times. Okay, now let's this is the last question. I'm picking this up as the last question for your arithmetic progression. This is a practical problem actually. So real life example. Here a man repays a debt of rupees 4860. A person is paying a debt of rupees how much? 4860. So how much did he borrow? He borrowed 4860 from someone. He is paying rupees 30 in the first month. So here first month he is paying 30. Second month, third, fourth, fifth. Okay, let's. Next, what happened? Then increases the amount by rupees 15. He used to repay rupees 30, right? Next one, second month, he increased it. He increased by rupees 15. Now, second month, he is repaying rupees 45. Every month, so you continue to increase every month. So next is you add 15 rupees more. So we get 60. Next is how much? 15 rupees more, we will have 75. Next is 90, and then so on. So question one, how long will it take for him to clear the debt? Okay, let's try to put the amount of money that he repay each month in terms of a sequence. Look, first he put 30, he paid 30, next he paid 45, next he paid 60, next he paid 75, next will be 90, 105, and so on. If you add all of them, how much are we supposed to pay off? We're supposed to pay off 4860. That means according to the question, this is the sum. This is the sum of money he borrowed is the sum of all the amount that he pays back each month. Okay, so these are the terms. This is the AP. This is the sum. This is the sum. This is the AP. So we have got A here. You can find out the D. D is 45 minus 30. So we have got 15. The increment that he add every month, that is the common difference. So we have got A, we have got D. We have got the total amount of money, that is the SN that we have to pay off. Question asks how many months will it take? That's like asking how many terms will it take to arrive the sum as 4,860. Question wants N. Okay, are we clear? I believe so. So let's write it properly. Let's do the solution properly. So we will say the amount of money he pays off each month can be written as. So we have got 30 as the first, next is 45, next is 60. So we have got A as 30, D as 45 minus 30, so 15. How much is the total amount of sum that we have to pay back? It's 4860. Sum of money to pay. How much is it? Okay, now we have got the formula for sum as n by 2, 2a plus n minus 1. Put in the value. The sum of money is the 4860. N by 2, you have to put it here. Twice a 2 into 30. N minus 1. D is how much? D is 15. Let's use the left hand side. Right hand side. So we have got 4860 is equal to n by 2 is still there. 2 into 30 is 60. You open this bracket, okay, 15n minus 15. So let's bring the 2 to the other side. 4860 into 2, how much is it? 0, 2, 7, 9. N is remaining. If I take 2 to the other side, it turns into 9720. Keep the remaining 60 minus 15 is how much? It's 45. We will put the 15n first. 15n minus 45. I can take out 15 as common factor. So 15n n minus 3. And bring this 15 to the other side, okay? So 9720 by 15 is equal to n minus 3. You can divide it. So 5 3s are 15, 5 1s are 5, 5 9s are 45, 5 4s are 20, 5 4s are 20. So you can cut with 3 again. 3 6 are 18, 3 4s are 12, 3 8s are 20. Okay, let me rub off the part on the right hand side, left hand side. So what we have got is n minus 3 is equal to 648. Solve this. We have got n square minus 3n is equal to 648. Make it a proper quadratic equation. Okay, now multiplication is 648, subtraction is 3, middle term splitting, remember? So 648, factorize it, 2 3s are 6, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 6 are 12, 2 2s are 4. Continue like this. Okay, what value shall we take in order that the subtraction is 3? Let's see. So 2 2s are 4, 4 2s are 8, 8 3s are 24, 3 3s are 9, 9 3s are 27. We can take 27 and 24. So this 3 here, it can be split into 27 and 24. 27 is this part, 24 is this part. So this is done. N square minus 3 is split at 27 minus 23. Let's open the bracket. So we have got n minus 27. I don't think I need to explain the middle term splitting and then taking common factor. We have done this so many times, right? I'm sorry, this is supposed to be 24. Okay, now take out the common factor. We have got n minus 27, n plus 24. So let's put separately n minus 27 equal to 0, n plus 24 is equal to 0. No need for the other side anymore. So from here, what we are able to get is n is equal to 27. This one is useless, n will get 24. Negative sign. The number of terms, it's not supposed to be negative. Okay, how many number of months? Minus 24 months. That doesn't make any sense. So from here, the number of months that it's going to take is, the n is 27. Just say how long will it take for him to clear the debt. So it will take 27 months. Okay, n is equal to 27. The n represented the number of months. N is 27. 27, if you calculate it, it will be 2 months, 2 years and 3 months, right? So you can just say here it will take 27 months to clear the debt. You can say here this part 27 months, you can say there's 2 years and 3 months, right? So 2 years it will take 24 plus 3. This is 2 years, this is the extra 3 months. Okay, with this your arithmetic progression chapter is essentially over. What I want to remind you all is you have to keep practicing again and again. Don't spare the solved examples. Solved examples, look it up. And the questions in the exercise also, you have to calculate it repeatedly again and again. Every time, see if what mistakes you can be omitted every time you do a calculation. So the less number of mistake there is, the more chances there to get full marks for the questions that you are doing. Okay, with this, we have to stop here for today. I will see you all on the next chapter. Goodbye.